Let's take a look at the graphs of some different vertical shifts. So first of all, let's look at f of x equals x squared. We're going to take that and add 2 to it. So here's our parent function, x squared. Now, what happens if we add 2 to x squared? Not multiply it by 2, add 2 to x squared. You can see something very easily visual happens. It's very easy to see what happens. It moves up 2 units. Okay, I'll do it one more time. Every single y value moves up 2 units. For example, the 0, where it was 0, 0, moved up 0, 2. Negative 1, 1 moved up negative 1, 3. 1, 1 moved up 1, 3. 2, 4 moved up 2, 6. The y values moved up 2, while the x values stay the same. Vertical shifting is probably the easiest to learn, even though it's the last one we're learning. We're learning it last because it's the last order when you do transformations. Let's look at square root of x. Okay, again, when d is equal to 2, all the x values stay the same. The y values move up 2. I mean, it's so nice to see something that's so easy to comprehend. Sometimes in math things are difficult to comprehend. Let's look at 2 to the x. Again, here's the original 2 to the x. If we add 2 up here, so 2 to the x plus 2 when d is 2, so we're going to call this one d. All the y values move up 2 units. Very cool, very easy to understand and comprehend. We can see that when d equals 2, the parent graph shifts up vertically, but why? Well, this is just like explaining vertical shift and shrinking. It's very easy to explain. So p of 1 is equal to 1 squared, which is 1 when p of x equals x squared. When f of x equals x squared plus 2, we're taking that original y value that we got, 1. We're plugging in 1, by the way. We're taking that original y value that when we got 1 and just adding 2 to it to get 3. So with the same x value, you get 2 more for your y value. I mean, it's just really that simple. Next, we can see that when d is 2, what happens to, for example, this point? P of x equals x squared. We know that p of 2 is going to be equal to 4. Well, if f of x equals x squared plus 2, what's f of 2 going to be? Well, it's just going to be whatever p of 2 is plus 2. P of 2 is 2 squared, which is 4. 4 plus 2 is 6. Therefore, we can see a vertical shift of plus 2 from 4 to 6 while keeping the same value of 2, x value of 2. And we can see it right here. F of 2 is 4. Sorry, P of 2 is 4. F of 2 is 6. It's 2 more than that. In general, we can see that when d is 2, you can take the original P of x value and add 2 to it to get the f function value. And that's because, okay, here's your P of x, right? X squared. Well, since P of x is x squared, we can just replace it with P of x and then just add 2 to that to get f of x. It's so simple, and we're going to see the same thing for when it shifts down. It's the same concept. Alright, so here's our formal proof, I guess. P of x is the parent graph and f of x is the transformed graph. And suppose f of x is equal to p of x plus 2. I like to make this purple because that's the way it is on the little app. So if f of x is equal to p of x plus 2, then we can switch that. So p of x plus 2 gives you the function value. And that's it, folks. It's that simple. In other words, the y values of p of x are shifted up 2 to reach the y values of f of x. Let's see what that looks like on a chart. P of x equals x squared. Again, here is our typical chart with our 5 x values here and our y values here. All we're going to do, if it's x squared plus 2, is, again, this is a vertical transformation, so the y values will change. Take these p of x y values and add 2 to them to get your function values of your transformed function. They're shifted up by 2, and therefore your final chart will look like f of x equals x squared plus 2. X values stayed the same. All of the y values were shifted up by 2 to get your new function. That's it for this video. If you have any other questions about it, let me know.